Okay, so indices, examples. Alright, let's choose a better color than this ugly olive green. Let's go with this one. Okay, example number 1. Nice and easy. X to the power of 5 times by x to the power of 3. Well, that gives me x to the power of 8. We add the indices. Number 2. Now what if I put a number in front of them? So what if I go to x to the power of 3 times by 3x to the power of 4? Well, the way I want you to always think of it as is do the numbers first for everything. In anything in algebra, numbers first, and then each respective letter. Okay? So you would look at numbers first. So here we go. 2 times 3. It's not 2 plus 3. It's 2 times 3. Alright? So 2 times 3 is 6. And then when we're looking at x cubed and x to the power of 4, since we're timesing them, we add the indices. See? Numbers are different to indices. Indices are up here, numbers are down here. Okay, so we add the indices, x to the power of 7. Number 3. Let's go with 4x to the power of 5 times by negative 2x to the power of 3. Alright, the number here is 4. Again, numbers first. So the number here is 4. The number here is minus 2. Okay? Don't think it's 4 take away 2. The number is just minus 2. So it's 4 times minus 2. And I just use brackets in there just for you to know. 4 times minus 2, which is minus 8. Alright, 4 times 2 is 8. And then the negative with the positive turns into a negative. And then again, x power 5 times x power 3 is x to the power of 8. Okay? Easy stuff. Number 4. Let's do division this time. Let's go with nice easy one first. X to the power of 8 divided by x to the power of, you know what? 7. X to the power of 8 divided by x to the power of 7. What's 8 take away 7? 1. But you don't write x to the power of 1, okay? It's not nice to write it. We usually assume if we just write x, then it is just to the power of 1. Okay. 5. Now let's put numbers. Let's go with 16 x to the power of 7, and then we're going to divide that by 4 x to the power of 3. Well, numbers first, right? That was our rule, numbers first. So 16 divided by 4, 16 divided by 4 is 4. Okay, because 16 is bigger than the 4, so 16 divided by 4 is 4. And then x to the power of 7 divided by x to the power of 3 is x to the power of 4 as well. 7 take away 3. Number 6. What if I change it and put a question like this? And a lot of people don't do this one correct. So what if I go 3x8 divided by 9x, and let's just do it as 6. Okay. Well, when I'm doing 3 divided by 9, it's not 3. It's 1 over 3. 3 divided by 9, 3 over 9 is 1/3. Okay? The other one you were thinking of is 9 over 3. They're very different numbers. Okay? So be very careful with that. They're different. They don't equal to each other. 3x to the power of 8 divided by... So 3 divided by 9 is 1 over 3. So as I said, 1 over 3. But now you've got x to the power of 8 divided by x to the power of 6. 8 take away 6 is 2. So you've got the x to the power of 8 being bigger, right, than the 6. So your x squared should be on the numerator. That's what this is showing you. So the same thing with this. 3 and 9. The 9 is bigger, so your 3 is going to be in the denominator. That's a good check to do. Okay? So anyways, 8 take away 6 is 2. So it's going to be x squared on the top. So you're going to times it by x squared, which simplifies to x squared over 3. Because 1 times x squared is still x squared. Right? 1 times anything really is that anything. Okay, and then you just get x squared over 3. That's it. So number 7 now. Let's go with a little bit harder. Let's go with 10x 5y squared over 50x 6y. Okay, well, numbers first and then each respective letter. So if I do numbers first, I'm going to go 10 over 50. 10 over 50 is simply 1 over 5. Okay, then we'll have a look at this. X to the power of 5 and x to the power of 6. Okay, well now if you did 5 take away 6, you're going to get a negative number. Right? So if you did 5 take away 6, you're going to get a negative number, and the negative's on the top. Right? So we don't want that as of yet. For now, the way I want you to see it is always follow the largest number. Wherever the largest number is. So 7 take away 3, it was 4, so we left it like that. 8 take away 6, 2. We're going to follow this number. 6 take away 5 is 1. But where's the 1 now? On the top or on the bottom? And it's on the bottom. And the reason why is because x power 6 is bigger than x power 5. Right? And then, anyways, you're doing 6 from down here, take away 5. Another way to see it is 5 can go into 6, and when you cancel it out, you've got 1 left over, and look, it's still in the bottom. So however you had to look at it, it would work out. Now x, but I'm not going to write to the power of 1. And then same thing here, we're going to do 2 take away 1 this time. There's an imaginary 1 there. Okay, I hope you guys know that by now. So 2 take away 1, and then we're going to do that as power of 1. So therefore, it's, and then it's y on the top. So it's times by y. So yes, you could have just gone and changed that 1. But again, we don't write 1y. It just looks pretty bad. So we just write y over 5x. Y over 5x. Okay? So 1 times y turns into a y. Let's do another one of those ones. Let's go with 25x 8 y 3 z 9 over 75 x 6 y 3 z 12. Thank you. Alright, here we go. Numbers first. 25 over 75 is a third. So the 3 is on the bottom, the 1's on the top. I'm going to omit the 1, knowing that I'm going to have leftovers here. So there's no point of writing 1 times y. I'm just going to leave it as nothing for now. Alright, here we go. 8 take away 6. 8 take away 6 is 2. Okay, leftover on the top. You see how I did that? I took all the 6 out, so the whole x, and then took just 8. 8 take away 6 gave me 2, so it's x squared. Now, when I go from y cubes, 3 take away 3 is 0, and we said anything to the power of 0 is 1. Or the way you should just see it is y cubed over y cubed cancels out. One way or another, but you're not going to write times 1, because again, it's not going to do nothing to your actual math in this case. Alright, and then we've got z to the power of 9 over z to the power of 12. Again, 12 is bigger, so 12 take away 9 is 3. And then you've got z to the power of 3. So yes, I did write it. I'll just write it again. I didn't change nothing here. But there you go. I did write a big fraction. That's because you don't know exactly what's going to happen there. Okay, I took account for the unknown. Alright, nice and easy one again. 6 to the power of 0, n to the power of 0 is 1. Question 10. How about if it was 6x to the power of 0? Well, that equals to 6. Reason why? Because the 6 is not attached to the 0. Okay, 6 is not attached to the 0. So it doesn't go there, and it's just 6 times 1. Number 11. What if I gave you 4x to the power of 0, like that now? Well, that's everything to the power of 0, and that just equals to 1. Nice and easy. Number 12, I'll just do on the side here. Let's go for 3x cubed. That's the power of 0. Take away 2 to the power of 0. Alright, let's do this slowly. So that's 3. It's not attached to the 0, so you just leave that as 3. x cubed to the power of 0. Well, everything to the power of 0 is 1, so that's just times by 1. So it's just 3. Take away, and it's not take away 2. That's what a lot of students try to see. It's 2 to the power of 0, which is 1. Okay, 2 to the power of 0 is 1. Be careful. And then 3 take away 1 is 2. Okay. 13. Let's go with now negative indices. So x to the power of minus 3, x to the power of minus 3, that equals to, as we said, negative fraction, and then 1 over x cubed. Negative fraction, 1 over x cubed. Perfect. Number 14. Three x minus 2. 3x to the power of minus 2. Okay, the 3 is not attached to the minus 2 here. So therefore the 3, does it go to the bottom? No, the 3 does not go to the bottom. It stays on the top because it's not attached. It's not attached. 3 stays on top. The x to the power of negative 2 turns into a positive x to the power of 2. The negative turns into a fraction. This question here, is the 4 attached to the negative 2? Yes, that's meant to be a 4. Okay, is the 4 attached to negative 2? Yes, it is. So my answer is 1 over, and then brackets, don't just write 4x squared, it's 1 over 4x all squared, which equals to 1 over 16x squared. And if you want to know how I got 16 again, that's how it would look like. Okay, when I expand that, it's 2 times 1, sorry, and then 2 times 1 here as well. So 4 squared, x squared. And then 4 squared is 16, not 8. Okay, another common mistake by students, they think that's 8. So 4 squared is 4 times 4. Okay, 4 times 4. $15. What if I put it, what if I gave you this? Okay, so let's go with x over y to the power of negative 3. Well, when I expand that, that gives me x negative 3 over y power of negative 3. Everything's attached, so the y's even goes to the power of negative 3. You get that? That equals to, it's negative on the top, it's positive on the bottom. It's negative on the bottom, it's positive on the top. Again, I'm only looking at indices, so don't think if I had a negative there, then that's the negative I'm talking about. No, that's a negative number. It's a negative index, okay? So don't mix that up by accident. Alrighty, and that's that one. Number 16. Let's go with x power of 3. Oops. 3 over 4. Okay, so what we learned from before, top, bottom, bottom. Hopefully we remember that. So then it just turns into this. X to the power of 3. It's on the top, and that must be on the little bottom at the, on your calculator. Okay. And then we've got question 17. X to the power of minus 2 over 5. And you know what, to make it even trickier, we'll put a 3 there. And we'll put it over 4. So 3 over 4, x power negative 2 over 5. Okay, well, is this 3 attached to the negative 2 over 5? No. Is the 4 attached to the negative 2 over 5? No, because there's no brackets. It's just the x that's attached to the negative 2 over 5. So the 3 and 4 cannot change. They must stay in their current positions. So you're going to have a 3 on the top, you're going to have a 4 on the bottom. Now, is the x going to change its position? Well, yeah, because it's negative. So it's going to be negative on the top, which means it's positive on the bottom. So therefore it's x to the power of 2 over 5. But then we just learned what we can do with fractional indexes. We can change them to surds. So again, the 3 doesn't change. The 4 doesn't change. This turns into top, bottom, bottom. And you're done. You just got yourself the highest mark possible probably in a year 8 exam.